Okay, guys, math 3 notes. Go ahead and go to your table of contents. Today we are going to do parallel and perpendicular lines. I forgot how to spell parallel for a second. Parallel. Oh my god, that's wrong. What's wrong with me? No, it's not. That's right. Parallel and perpendicular. Okay, these should be a little bit shorter notes. So turn to whatever page you are doing that on. It's only going to be one page if you want to mark that now. Top line, side line. Pause it at any time that you need it to. Parallel and perpendicular. We're going to start with the definition. We're going to start with parallel. Parallel lines will never cross. And have, and here's the big one, have the, I'm going to use my highlighter here, same. I'm going to highlight that, same slope. Perpendicular lines will cross at 90 degrees, and their slopes are opposite. So if one is positive, the other one's negative. And reciprocal. So there are fractions that are flipped. I'm going to highlight this. Opposite and reciprocal. So that one has 2 highlighted. One of the little tricks with them are their products, the slopes products. Will be equal to 1. So we're basically going to do an example with one line. So I'm going to make a big giant coordinate plane. And I'm going to use 2 different colors for my parallel and perpendicular lines. Again, pause it if you need to. So the line we're going to be comparing these to will be, have a y-intercept of 2 and a slope of 1/2. So this is going to be the graph of y is equal to 1/2 x plus 2. So our y-intercept is 2, and our slope is up 1 over 2. I'm going to mark that as y is equal to 1/2 x plus 2. We're going to start with a parallel line. So I'll do parallel in red. So graph the line. Parallel to y equals 1/2 x plus 2. So the one that we've already graphed. That passes through the point -4, 3. So I know that parallel lines have to have the same slope. So y is equal to 1/2 x. I don't know what the b is. I could do it algebraically, but if I have a graph, I could actually just use the graph. So I'm going to go ahead and graph this point, -4, 3. 1, 2, 3, 4, up 3. And now I know that the slope has to be exactly the same. So this line, the slope is 1/2, so this line is going to be up 1 over 2, up 1 over 2, up 1 over 2. If I graph that, you can see from my graph that those lines will not touch. And the y-intercept of my red line is 5. So it's going to be +5. This is the parallel line. And this is our point, -4, 3. Okay, now I'm going to do the perpendicular line. I'm going to do it in blue. So perpendicular. So we're going to graph the line. Perpendicular to y equals 1/2 x plus 2. That passes through. Three, -2. So I'll zoom in. So the slope of our original line was 1/2. So that means if this is the slope of our original line, our new slope, since this is positive, our new slope has to be negative. And 1/2 has to be the reciprocal. So the reciprocal of 1/2 is 2 over 1. You flip it, which is just -2. So the slope of our line is going to be -2. So I'm going to go ahead and graph that. So I'm going to find the point 3, -2 over 3 down 2. So that's the point 3, -2. And now I'm going to use the slope to find my next point. Down 2 over 1, down 2 over 1. I could also work backwards, which gives me our perpendicular line. So if I look at our perpendicular line, it goes through the y-intercept there. So our equation for it will be y is equal to -2x, +4. If I was to try multiplying the slopes, I could do that real fast. So multiply slopes. I'm going to zoom in. 1/2, the original, times its perpendicular. Multiply straight across, -2 over 2. Your slopes will always multiply to -1. Their product will always be -1. Which I now realize I made a mistake. Up here, let's fix this. Their products will always be equal to. Let's fix that. It's a -1. Because they're opposites. One's a positive, one's a negative. See?